Hello.
Hi, how are you doing?
Good, yourself?
Good, thanks. It is the end of week 6. We still got a little more to go, and then we're third way done. So we'll finish soon. It's almost the weekend. It's warming up again, right? Okay, let's check out your lab for today. Let me get my REPL open. You can open your Visual Studio, your IDE that you're using. I also get my document open here.
Professor,
Yes.
this is Matt. My power went out around my like a 5 block radius where I live.
Okay.
Been out like all day, so I'm at like 25% of my battery left because my power bank ran out. So if I
Totally
disconnect,
understand.
okay,
Yes.
yes, thank you. Sorry about that.
Not a big deal. Yeah. So if you need to check the content, the video will go up tonight. But there is a video on the playlist already from last semester. So same lab.
All right, thank you.
Yeah. Yeah. No problem. I used to be a stickler about attendance before, but since COVID, I'm not. I became very flexible because now that we record videos and put things up, you can always access it. Before it was just in class. Sometimes that will be harder to really get the content, but you know, it's fine. I understand circumstances. Let me double check everything here. Ensure I have the right version. Okay. So we are going to do a little bit of random today. Oops, sorry about that. Let me lower this. Still very loud. Okay, so we are going to work on random today. We'll start in about a minute. So if you want to check out your lab, and then I'll go into screen share shortly. Let me just get my REPL folder open. So before we start, I have a minute. So if you live in Moreno Valley, you are Moreno Valley students, they have this thing called Mobile Learn. And I shared with my class last night. It's a way that you can get a little bit of money while going to school. And then I'll drop the link on the website there. And if you're interested, you can apply. Okay. They do this every semester. So, and then there's a couple of the things that they wanted me to post. I just haven't had time. So I'll put that up in your announcements. Let me drop this in the chat real quick. Okay. So if you're interested in this to be able to get paid to go to school, it's like earn and learn program. So you can fill out the interest form. It's like 8 questions, and then they will reach out to you and let you know. Okay. You're welcome. And I'm still waiting for the computer science scholarship money to get in. So hopefully they'll get that in before the end of the semester and I'll let you know. And you can apply for that. Okay, so let me share screen. There are quite a few employment opportunity. I think there's another program that's being done through the state, and computer science and CIS is part of it. I have the flyer. I will share on the announcement. So when you get a chance this weekend, you can take a look at it. And if you are interested, you can go to their info session and then you can apply. I think a lot of it has to do with getting work while you're in school, but they will cover like your tuition or they will support you in somewhat. And tuition is so expensive nowadays compared to before, and it's always going to go up. So those type of things, and then if you can have a secure job at the end, it's always good to have that in the back. And so let somebody pay for your school and then be able to also give you a job. There's also a lot of really different incentive to really build the technical workforce for California. So there's a lot of funding that goes into that. Okay. Does homeschool matter? Like it's not MVC? From what I know for the Moval Learn, let me double check. If you go to the About tab, let me share screen so you can see. I believe, so it tells you here that it's just you have to be a resident who are enrolled in any of the CTE courses, and this falls into the CTE, career technical education. And if you're able to, you can receive stipend. It didn't say anything about homeschool. I assume that it might be required. And then, yeah, okay. Okay, that's good to know. But, so if you want, you can check this out, but it does say about residents. It could be California residents. But this, you can click learn more, and then you can go and you can apply. It's like 8 questions. Okay. So I know the staff that work on this, and so they'll reach out to you and they'll get you started. Okay, so let's talk about C++. So this is the lab for unit 6. Okay, you can download it. And keep in mind that in this lab, we are going to simulate dice. So the way that we can simulate dice is to use random. And I always like to explore this concept is because it's commonly taught in computer science. You are going to use different library for random. And we're going to talk about random, what makes it random and pseudo-random. So in this lab, it starts with talking about generating random number. And you might have to create a program in future classes or for your career where you have to create random number. For C++, you can use the function called srand. And this allows you to generate random numbers depending on how you wanted to type it. And so when we say seeding is the starting point of your first number, okay? And then usually a lot of these library, what it does is it's going to have a starting point, a seed value, and it would apply the algorithm on how they would write that into the library. And it's what step through, that means that it's going to increment as it goes, and it's going to put in the random value. So you would have a seeding rand function, S stands for seed, with the starting point. Usually random numbers are calculated by taking the previous number or the seed and then do many operations on the number to generate the next. So when you see srand, you would know that it has to have a start number and it would utilize the prior number to be able to build the next random number. Okay, so our question throughout the session today should be, is it truly random? So in order to generate random like number, remember, random like number, srand is usually utilized to some distinctive runtime value. So to make it look random, we have to apply the time, and that will come from your runtime. So like the value would return by the function time, and so therefore we would use C time in the header. Now, whenever you see the .h file, that is commonly used in C, but you can implement that in C++. So that's how we can bring in the header file. And so in the dice, the scenario for our first exercise, we would simulate 20 rolls, and each die has 8 sides. So we would have 1 through 6, just like our assignment. And it's going to print each of the roll that it's going to the result from each of the roll. So we would then need to prototype, or the function prototype for the function rand is coming from the stdlib. And so we would then use the mod operator, which is the percentage symbol, and we want to implement that with the rand function. So we would then mod 6. Why is it 6? It's because there's 6 sides to your dice. Okay, and so that way we can generate integers from 0 to 5. And we would then need to scale it so that way it looks like it's giving us the result for the dice that's being rolled. We would then shift the range of numbers produced by adding 1 to the previous result. So that way it would look that the number would be differ from, one compiler to another that would supposedly be random. So that's the scenario for our example 1. We would have 20 rolls for the dice. And I believe, did I put the information? Okay. So if you're using the C++, you like in Visual Studio, how you're going to get the .h in there, make sure if you're not sure how to do that, make sure you watch the video. So I put a couple YouTube video up on how to do that, so you can check that out. Okay. Now, so then we would have IO stream. So let me open up the program that would help, right? All right, so we have the normal std, which is IO stream for C in, C out. We are going to use stdlib, okay? And we have using namespace std. Everything is built into the main function. So we are going to iterate using a for loop. And that's how we're going to go for the 20 roll, okay? So we have int I, that's going to be your counter. And then your for loop, you're going to start with 1 and you're going to go up to 20. I think I modified this. Let me check. Yep. So if you wanted to roll 20 times, you're going to go up to 20. And then you are going to do a mod 6 with a rand function. And like I said, we are going to add the 1 to it. So it's going to look different subsequently. Then when you have this for loop, you want to nest it with an if, okay? And so this if you read the comment, it says, if the counter is divisible by 5, begin the new line. So this is just for format purposes for the output. That's all it is, okay? So that way it looks organized when it comes out. So then we would then return 0 at the end. So when we run this program, it's gonna tell us, right, why we modding 5. We're gonna have 5 per row. Okay, so I have 2, 5, 4, 2, 6, 2, 5, 1, 4, 2, and so on. So this is just to keep, 5 numbers per row, so it looks nice. All right. Now, if it is really truly random, and notice that I'm not including time in this one, right? Like we did not add in the time library, and we did not implement any kind of time component to this. And it's using rand, not srand. Okay. And what we would see is that when you use this type of randomized type of mechanism with a function, you would see that it is pseudo-random in that it looks random, but it is not truly random because there is no runtime element added in. So when you run this and you run this again, you would get the same result continuously. See that? I would have 2, 5, 4, 2, 6. And if I go again, same thing. If I go again, same thing. Okay. So then we would say, well, if it's really random, then it should be different every time, right? So for the first example, basically it just simulates your 20 rolls of your dice. And how you're going to generate the numbers is when you would use some kind of randomized function, and then you want to mod it by the number of sides on that dice. So if you have 8 sides, then you would do a mod 8, right? So what I want you to do is for number 1, you are simply going to put this program into your IDE, okay? And then you're going to run it. You can take a screen capture. The reason why we're doing this is we wanted to see how we would be able to write, right, like a dice program, and we want to apply the probability. Then we wanted to calculate the probability of obtaining a 1. If I just want to get a 1 out of the 6 face in 1 dice for the 20 roll. So if I do 1 roll, that will be 1 out of 6. But since I'm doing 20 roll, right, my space, my sample space is larger. That's what you learn in the on Tuesday when we talked about the concept with the probability. So my sample space is going to be 6 to the 20th power. Okay, because I have 6 face and I'm rolling it 20 times. So then I would know that for the 20 rolls, it's going to be 1 over 6 to the 20th power. Okay. So here I state that so you can see the difference. So if we have 1 roll, it's going to be 1 over 6, and 20 rolls, it's going to be 1 over. Let me remove this and put this over here. So that way you would know. Okay, so when we approach this, just like before, we determine the sample space, and we're looking at what the question is asking. That's going to be getting a 1. Then if we are going to calculate the probability of obtaining other number that's not 1, right? Like 2, 3, 4, 5, 6 in the 20 rolls. So we would do the same thing. Okay. Then we would have 1 minus 1 over 6 to the 20th power, which gives us 5 over 6 to the 20th, because the 5, 6 is every other number. So it is a complement of what we had in A. So we simply take 1, subtract 1 over 6 and raise it to the 20th power, which gives us 5 over 6 raised it to the 20th power. because you have 5 other numbers that is not a 1. So any question with A and B? So after we run the program, we simply manually calculate it. So we have an idea, right? Because the program itself doesn't really give you a percentage. It's not designed to do that. It's just designed to simulate the outcome of your dice being rolled. And just like, so I wanted to use this, and the way I approach this is I wanted to take the program and I want to use it as an experiment, where in that when I run the program, I wanted to see how often is each number gonna come up. And that's gonna be able to, for us to really look at the scale, right? Then we can determine if the algorithm in the program to simulate the dice is really representing the probability that we calculated. Okay. So because the program works and it looks like it's giving us the result, but is it really represent the actual reality or the real world application in mathematics? So with that, what we have to think about is, yeah, your program is going to show that it's rolling a dice, but is it really accurate? Is it really represented what we see realistically? Okay, so then for C, we are going to look at the program and we are going to look at the scale. Just how often, so we are going to look at the frequency of each number when it comes up. Okay. And as you see that this is not a true random, as it's the same every single time that I run it. Okay. So you simply, to look at the scale, you are going to count up the number that shows up in the result. So if I look at the number 2, right, it shows up 1, 2, 3, 4, 5 times. Okay, so we can say 5. And then if I look at the number 4, I'm sorry, 6 times. I was right the first time. 6 times. If I look at the number 4, I can count up the how many times that the 4 comes up. So it's scale at 2. Okay. And then you can do, let me repeat this. Okay, so how many times does each number scale? So then we can make it order, right? So 3, so easier to track. So for the 3, I have 1, 2 times for 3. And then for 4, I have 2 times. For 5, I have 1, 2, 3, 4, 5. So 3 here, and then, yep, 5. 5 times. And 6, I scale for 6 2 times. And then is there any time that it shows a 1? There are 2, 3 ones. So 1 is going to be 3 times. And if we repeat the process, we would then see that it's still the same the next round. It's still going to have 3 1s, right? 6 2s, and so on. And based on this result, you can start diving in and you can say, okay, well, what's the probability of the number one coming up? And that's why I staged the question A and B. So a program is only accurate as its programmer, right? When you produce something, it doesn't always mean that that should be correct or it is correct. So what you have to do is in programming, we have to come back to discrete structure concept and we would say, is that really representing what we would see outside? Okay. So based on the frequency, you can start seeing, even though it's pseudo random, we can say that, okay, so what's the probability here and what's the probability here and here and here and here? And does that represent what we would see in the probability concepts? Any question? Okay. So then if we just purely look at the 20 roles in the outcome, okay, not the face with the probability, but the 20 roles that in the result, we can say that, you know, out of the 20 times that we roll, we would have certain number. So for example, 2 is 6 out of 20. Okay. And then for 1 is 3 out of 20. And for 3 is 2 out of 20 and so on. And we would see what is going to be the highest for the frequency, which one scaled the most. And it seems like based on our result for C, 2 comes up the most, right? It has the highest scale. So then you can look at the number 2 and you can say, well, my concept, if we're just you know, we are not saying, let's say that it's just rolling the dice, we can apply the inclusion and exclusion principle and we can say, well, what is the probability of 2 coming up in the 20 roll, right? And just like how what we calculated up here and what would be the others. So what this exercise is designed to do is to help you think about how you approach your solution, in this case, simulating the dice, and looking at the probability so that way you can revise your algorithm and making sure that your algorithm represent what it should be realistically. Okay. Yeah, I know it's easy to copy a program and run it, but we have to think a little bit deeper about, you know, is that program accurate? Is the algorithm, is what's there enough, right? It's producing something and it works, but does it mean that it's true? Okay. And lastly, what we would see is, like I did before, we would test it multiple times to really see that is it the rand function as it's used, right? It's going to produce the same result. And so therefore it really doesn't make it a true random outcome. Question. Okay, no question? Then for G and H, what we can do is we can, let's say we modified that and see if it's going to give us something slightly different. It should, right? Let's say that we don't use the standard dies. Let's say that we use an 8-phase dies. And we want to throw that dice and see. So what you're doing there when you're changing a 6 to an 8 is that you increase your sample space, right? With that, you have to take a look at how that affects the outcome for the probability, because now you have a larger sample space and how your numbers are going to scale. So we would then, let's say we change this up, instead of the 6 phase, we would make it 8. And we can still go with 20 rolls, right? And then so for now, what we have is we have different scale with higher numbers, right? So our range of numbers has changed. And then we will take a look at that scale, how frequent each of the number is, and then weight that against. So the probability of your outcome from the program, and then compare that to what it should be as a probability for a certain number to come up. And that's what I'm trying to get at with this particular exercise. So to really elevate this type of program, right, you can do a lot of things to it, right? We can create its own function, right? There would be, implementation of functions to really build out the algorithm, to really simulate the dice that would represent the probability. We can also add data structure to it, class objects, the whole works with C++, right? But ultimately, one area that it's lacking is going to be the time to make it like it would be true random, not because it's just pseudo random. So every time that you run the program, it should give you different outputs. Okay. So for G, you would modify that, and let's change that to 8 to make our sample space larger. We would run the program and take a look at your output. And then again, we are going to scale for the number because now we have a larger sample space. So you can then again put in, let me put some example here. Okay. So we can say that if we start with 1 only come up 1 time. So you can say 1 is 1 time for frequency. 2 is just like how we scale for the other one. 2 times. And then 3 is 2, 3. 3 times 4. So 4 times that it appears. And then 4. And so on, right? 1, 2, 3, 4. Also 4. And dot, dot, dot. So you can add more to it. So once you have your scale, then you would be able to answer J. Which number appears the most in the 20 rows? Okay. by just looking at it, right? 4, 3, 5, 3 times, 4, 3 times, actually 4, 4 times. Okay, so looks like 4 appears the most. So then we need to take a look at what 4 should be in the probability for the hit with 20 rolls and 8 face. Okay.
So, Professor, I have a quick question.
Mm-hmm.
Going back to F, you were saying about the I guess how incorrect the regular random function is. So
Mm-hmm.
what would the difference be between the srand and the regular rand function?
So in the srand, you're gonna have the seed, but using the srand, you have to implement the time, and we will see that at the end. Yeah.
Okay.
So these random functions, it's designed to produce random like number if you don't put in the time component. Okay. So the objective of this is to show everyone here in this class that when you randomize things, you have to also implement the time component, and also writing a program that shows the probability using random is not always accurate. So you
Hmm.
have to weight it against what you would calculate, right? Because math is going to give you the outcome that should be correct. So you have to really look at how that would be solved into your programming. Okay, so you have to approach it from a probability standpoint. Uh, because if you are looking to do an application that would, let's say for life or death situation, something that hospital can use, you want that to be accurate. You want that to be, because that's essential. Okay, not just to produce something, anybody can see out everything, right? So
Right. Okay. Thank
yeah.
you. Appreciate that.
Yeah, and this is not busy work. So I want you to think about, like, how would you approach this, right? Like if you were to rewrite this program or improve it, what other things can you make it as realistic as possible? Okay. And yes, there is limitation in the language that we use and the compiler and all these other area, but outside of that, we're going to try to get to, right? So we want to make sure that we get to less of an error and reduce that margin of error and be able to be closer to what we should see as the output. So that's important. Okay. So I want you to see the frequency and how that comes up, because if you look at the probability for that number to show up in the roll, right? Should that be less frequent in the 20 rows, right? So that way you would see that, oh, well, the function I'm using, it's not doing that for me. So maybe I have to customize the function. Maybe I need to implement my own algorithm that it's going to need to step through. And so now also, I want to point out that random in almost all languages, you should use things with parameter, which you should put parameter in there so that way it would take that parameter and apply it, right? We just simply use it with a mod, and that's not enough. Okay. All right. So after we scale for J, we wanted to look at which number appears the most. And then we want to increase the roll so we can see. So again, like I said, we're going to treat this like an experiment to really tell us, is it good or bad with the implementation of the algorithm that we have? Okay. So we're gonna we're gonna increase this. And as you increase, right? This, your exponent should be a lot higher, right? Because we go from raise it to the power of 40 now instead of the 20. So that means that these numbers are coming up. That should be, that should be parallel to what the probability concept would be. So what you would have here is you would see, 8's going to come up. In this one, it had 1, 2, 3, 4, 5. I have 5 times for 8. And yeah, you can start scaling it out and you can see, is it accurate that those numbers are come up more frequent? Okay. So once you increase that to 40 rows, right, we run the program, which number appears to be the most frequent in the 40 rows. Okay, and then think about its probability. I didn't ask that question, but you should think about that. Any question with these? So when we start doing, solving the problem using programming, you need to plan out on how you want to be able to check your algorithm and, because sometimes, we gotta wait in things like, there's limitations in software in that it might not really address the solution 100%, but for most part, okay, is that good enough? So in this case, we can see that it's not accurate, so therefore it's not good enough. And so we have to revise the application, rewrite it, and be able to improve it. Okay. Any question with the one? So then we will do number 2. And for number 2, I want to give you a background on it, right? So to show that the numbers occur approximately with the equal likelihood, we would then need to simulate it with more rows. Okay, we can put it through 6,000, 10,000, 1,000 times. So in this case, we're going to simulate it with 6,000 rows. And we are still going to use 1 through 6. Okay, which should appear approximately 1,000 times. And we don't want to see out 1,000 times, but we have to find a better way to really show it. So this is another approach to the dice problem, right? We want to simulate the dice and we wanted to see the outcome of it. So let me put this back so I don't forget next time. 6. And let's go to number 2. So in this one, for number 2, we are also just have a main function, and inside it, we would implement our algorithm. So you have variable that's going to store frequency for each of the phase. If we roll for 1, for 2, for 3, and so on to 6, we're going to have a counter, which is going to be the roll. It's going to count the number of rolls we have. That's going to be from 1 to 6,000. And we are going to have a variable that's going to be a phase. That will be from 1 through 6 for our dice. And what we're going to do is we're going to loop it 6,000 times. So it's going to start at 1 and it's going to count to 6,000. And in this one, it's also using rand. And we're going to mod 6 as it is 6 phase. So pretty much the same as the last one. But what we're doing here is that we're counting the frequency of a certain number come up and we're rolling more. Now inside the for loop, we are going to nest switch case. Okay. So for case 1, that will be for the frequency 1, case 2, frequency 2, and then we want to have the break in between for each, all the way to frequency 6. And what it's going to do is going to store that and it's going to bring that into the display for us. So we're going to measure the frequency of our dice outcome. All right. So a little bit different approach than the last one, but ultimately we're also going to use the rand. Okay. So it tells us that we are close to the 1,000 for each of the number. Because why do I say that, right? Why did it say that? Is because if you're looking at for one number out of the 6 for one roll, okay. But then if you're rolling 6,000 times, so you have enough information here that you can put into probability calculation. And then you can determine, right, how each number would be. If I get a 1, what's the probability of getting a 1 in a 6,000 roll? Okay. And, you know, my sample space for the 1 dice is 6. So 6,000 roll, and I'm going to increase that, raise that to the power. Because this is when you choose 1, right? Going back to the last unit, when you choose 1, this is not a permutation in that it's a combination in that when we choose that one phase, it's still going to be reused in the next roll. Okay. So all of this is all related together. All the concept that we go over, it's going to build on one another. So you will see. So there's the program. Okay. And you can run it, take a screen capture, and then you run it a few times. Is the result different? Okay, so let's run it again. Phase 1, 980, phase 6, 986. We already know because when you're using rand like this, you know that it's the same every time. Okay. Okay. So then we are going to scale. And this one, it's already counted for us. So we can look at the number and compare, right? Which one's the highest number? your phase 3. That one has 1,030. The second highest is going to be phase 4, and then 5, and so on. So we would then take the frequency of that divided by 6,000, because there's 6,000 roll. We have 1,030 times that number came up. So in the probability calculation is that we know that it's going to be 1/6 raised to the 6,000th power. Is it comparable? Now, if we also look at the lowest frequency, okay, the lowest going to be 980. That's for phase 1. Then you can say, okay, we would take 980 divided by 6,000. Is it comparable to 1/6 raised to the 6,000? So now what if we reduce it down? What if we want to go with lower number of rolls, right? And we can take a look at how the numbers would scale. How often is it going to show up with the 100? So that's easy. We can go in here and then we can change this to 100. Then we're going to run it. So if you roll 100 times, this is what it gives us. The outcome of the program shows us that phase 3 still has the highest, right? And 5 and 6 is tied for the lowest. So we would say that we would take, based on this, right, 100 times, the number 3 show up 23 times. So we would take 23 divided by 100. Is that comparable to 1/6? Raise it to 100. And for the lowest, which is phase 5 and 6, we got 12 times that those phase came up. And so we would take 12 divided by 100. Is that comparable to 1/6 raise it to 100 power? So I put the 1/6 there, right? You can add notes to it because, you know, months from now you look back and you're like, what the heck did I put here, right? What does she mean by 1/6? So that's the actual probability calculation. And the other one is out of the program outcome. So we have to take a look at that compared to what it should be. And then we can try again for 1,000 roll. And you already know, right? No matter what you change here, So in this one now, we would see that phase 4 got the highest. We have 181 times that 4 came up from the dice roll of 1,000 roll. And then the lowest would be phase 2, which we got 150. So in the outcome of 1,000 roll, we would see that if we take the outcome from the program, that will be 181 for phase 4 divided by 1,000, right? But the probability calculation of that phase comes up in 1,000 roll should be 1/6, base it to 1,000. And for phase 2, for the lowest frequency, that will be 150 over 1,000. And again, we got to check that with the actual calculation. Okay, so as you can see, right, we have a program. It looks like it works. It gives us the frequency of the outcome for our dice from 100 to 1,000 to 6,000. But does it check against discrete math? So in the last part, we would say for F, we would compare. Let's say that we look at the result from exercise 1, which we only roll 20 times and 40 times, and we're still using 6 face dice, and we're still using rand mod 6. Right? That's the similarity is that we have the implementation of this, right, is the same. Now, to make it really count up the frequency of each number is that the second program applied, right, switch case, and we created the variable to store those values for the count of the frequency in number 2. And we also increase our loop. So we iterate higher. We would go to up to 6,000 times for the first round. So what I want you to experience in this is to make an observation, right, on how each program is approaching this particular problem to simulate the dice and its outcome, right? The first program produced the actual number, and then we just got to count it up, but it still does it. And you can just simply write one line in there to make it count everything and give you the output, sure. But, you know, we have to think about how this is giving us the randomization and the output for our dice. Now rand is going to seed at the same position every time. So this is where you would get the same output every time. Okay. Question. So for F, what is your general observation that you can draw from rand from exercise 1 and 2? After you describe the differences and the similarity of these programs. And you see in almost all programming language, you have this, you have random, right? You can implement random. And I know for Python, when we do it, because I just went over NumPy with my class and we use random. Right, we import in the library and then we use the method for it. So I use it to generate arrays all the time, even yesterday. So you have to weigh in and look at the library, how the method is written. You know, if it's the algorithm applies, and you have to consider having the time component in it. Okay, so we will get to that in the next exercise. Okay. Question. All right, so the next part is about looking back into exercise 2. So it says that in the previous exercise, exercise 2, rand generates pseudo-random number. Calling rand repeatedly produced a sequence of number that appears to be random. We learned that already, right? However, the sequence repeats itself each time. So whenever you run the program, you get the same output. And so it repeats itself each time the program is executed. This can help you debug your program that uses rand function. Once the program has been thoroughly debugged, it can be conditioned to produce different sequence random numbers for each execution. This call randomizing that can be done using standard library function srand. Srand takes unsigned integer as a parameter and seeds the function rand to produce different sequence of random numbers for each execution of the program. So it's still using rand in the back. The main difference is in that it seeds different number, okay? And that makes it look random. So now, number 3. So in this one, it looks like the first one that we've done, right? Very close, except for a couple areas. So we would take the first one and then we can modify it. So then in here, you are going to use stdlib. You are going to use the time std c time. And so with that, we can implement the time component. Okay, so this shows you how you can use srand. So in the main, you have int I, which is going to be counter. That's simply just for index. And you have srand. And in this srand, you are going to use a parameter. And the parameter is going to be time, and it's going to be different every time, because if you run it 5 minutes from now, it's going to be different than currently. Okay. So we are going to pass time and null. So that's going to be our C. And we are going to loop. So we use a for loop. It's going to start at 1. It's going to go to 20, and it's going to increment. It's going to count up. And we're still using this. So 1 plus rand mod 6. And this is just to organize the column for output. So there, after I run it, I would have 2, 5, 2, 3, 4. And I can look at the scale, right? In this one, I have 5, number 6. Okay, I can just look at the first row. And then now it's different. And again, it's different. Okay. So it gives you the random element by using srand time null. So from here on out for C++, right? Anytime that you want to generate random number, you use srand time null, and you got to bring in time std, C time std. Even though we have that here, we can still use rand to operate with the mod 6, right? Question. Okay. So there's our program. You got the screenshot there. And here it touches on the srand time null. And it says that this function causes the computer to read its clock. And it's going to take the value from the clock, and it's going to seed that automatically. So that is different each time that you run it subsequently. Function returns the number of seconds that have passed since midnight, January 1st, 1971. And that's, that's standard for UTC. Then that value is converted to the unsigned number or integer and used for seed to randomize your number. So your null argument, it will be able to take that, and it is found in the C time library. So in number 3, it says that in this program, we explore srand function, run the program, give me the screen capture. So I just want to see you did it. Run the program 3 times. Are the results different each time? It should, right? Because you have 3 different point time. So that should give you the different output. And if we want to get one phase, which is phase number 6 in 10 rows, what would that look like? So 1/6 and raise it to the power of 10. So when we scale the number, now we got to check the frequency of the number. So going back to the program, I see that 6 got 5 6. 6 has 6. And I'm going to go down 5. We can take a look at 5. 5 has 1, 2, 3, 4. So 4 there. And then 4, we have 3. And then 3, we have also 3. And then 2, we have 2. And then 1, we have 2. So 3 is 3. And then 2 is 2. And then 1 is 2. So we can scale it out. And then the number that has the lowest frequency, we can see that will be number 1 and 2, right? Oops. I meant to put my cursor there. And then you can. So the outcome for those, right? 1, it has 2 out of the 10 rolls that came out. And then 2, it has 2 out of the 10. And what is that weighting with the? So if we do 1 roll, right, that's different compared to 10 rolls. So then you would have 1 to the 1 divided by 10, 1 divided by 6 to the 10th power for the 10 rolls. That should be for each number. So now if we change the rolls value to 20, and then we run the program, is the output different outside that it's going to have more, right? So what we have is we're going to increase the exponent. Okay, so then if we change this, well, before it was 10, sorry. We run that for 10, it will be that. And if you run that for 20, so I think I scaled it wrong, you guys. Yeah, because the program originally had 10. Let me rescale that. Let's go back and make it 10 here. And so we have 1 6, 2 5, 3 5s. And that's going to be different every time we run now, right? So yours is going to be different than mine because we're not using just rand. We also have the time element. And then 4 is 2. So you just got to scale it out. Okay. And then 3, I only have 1 time there. And then for 2, I have 1 and 2 for 1. So my lowest is actually just the number 2. That is 1. One time that it shows up out of the 10 roll. And okay. Then we modify this for E. So we're going to change this. We're going to do 20 here. run it. So the output is definitely different, right? I mean, it's still going to be 1 through 6, but you have more. So you can make your observation there. Is the output different from 3A?
Professor, for D, I have like 4 or 5 of the numbers are all at 1.
Yeah,
So is that
that's
okay?
okay.
That's good to
Yeah.
list them? Okay.
Yeah, because also this is, we have to wait in your processor, and because it's using the system clock, which is from your processor. And then, yeah, so yours and mine and everybody else will be slightly different. And then we also run it at different time. So yeah, it's gonna be different for this one.
Okay. Thanks. I just didn't know if I should list all of them, but I could.
Oh
Okay.
yeah, so the probability is the same. If it's just 1 for like 3, 4, and 5, then
Right.
yeah, it would just be 110 and 1/6 to the 10th
Oh,
power.
okay. All right. So just like how you have it. Okay.
So when we increase that, we answer that question. Then F, what is the number with the highest frequency? So on mine, right? Let's see, 6 comes up the most, I want to say. So I have 1, 2, 3, 4. Actually, that ties with 5 because that's, oh no, 5 is more. I miscounted 1, 2, 3, 4, and 5. 6 has 4, so 5 has the most. 5 comes up 5 times. And if it's just that one phase that's supposed to come up, for the probability, we would then need to raise this to, oh, let me put it here, 20 for the 20 rows. And then the lowest frequency, you can look at the number. Again, we would check that. And then we would compare between the 10 rolls and the 20 rolls. How are the results? From the program itself, right? So I see that for F, I have 520 compared to oh, I didn't ask for the, oh yeah, I did ask for the highest frequency. I just didn't answer it. So compared to the other one here, where it would be 3 divided by, what was it, 10? And that was for number 5 here. So after we compare the result from the program between the 10 and the 20 row, right? Are there any kind of differences or similarities? in the lowest frequency and the highest frequency. In this one, as it has the C time, you won't see it as, you know, the same throughout. So and we can draw a conclusion on comparing RAND to srand that we use today. What is your main conclusion? So RAND is not really random, right? Not without C time. And I believe in CIS5, there's, you know, if they're using the same book that most of us use, then you should also have a chapter on this too. And so also 17A. And srand, you had used, you implemented a parameter, right? You put in the time in the argument and you use it with no, so it plugs in your clock time. And so if you run it right now, it's different than when you run it later. Okay. I like using random in programming class because it's fun to use, and you know, you do see results and you can analyze the result and you can play with it, and then you can read more about it if you really want to know what's inside these functions, how it's written. Then you can go and you can look it up and see how to implement the algorithm. Okay. But now you should understand the difference between RAND and srand by just doing these dice game and looking at the probability that we learned earlier this week. We apply the concept, we look at it, how it's used in programming, and we also look at the type of library that we implement. Implementing the library is not always the best, right? But it's definitely convenient for sure. It's just we have to make sure that how we use it is going to fulfill the objective of your program, that it is accurate, it is efficient. Okay. Any questions on these? I know it's pretty light, so, but it gives you time to kind of go and look at your program. And then, you know, if you wanted to research additionally, you can.
I had a question, Professor.
Mhm.
So if we run the program and then let's say the number doesn't appear at all, would that be the lowest frequency, or would it just
Yes,
be?
that will
Yes.
be the low.
Okay.
Yeah, 0. Mhm. Yeah, if it doesn't show up. I originally had additional stuff in this, as you can see in my folder there. So in the past, this class, but as I was going through it and I was reading the student response and in the assignments, I felt like those, it was confusing to them. So I took them out and I stuck with these 3 because cohesively it gives you the overall view of how you would approach solving one type of problem, and to really use a certain type of functions and be able to really take a look at the program itself and see how you would debug it or improve it. Okay, instead of throwing a lot of things. Yeah, we can do a lot of things with probability, but you know, just having that perspective on doing a simple program like this, just using, you know, the built-in functions and see how that built-in function is going to give us the right result is important. Okay. And I'm happy to say that in the last few classes, I do see the difference in how student program from the beginning until the end, even though a lot of the things that we do, like you just basically use a program that I provided as an example, but I see the implementation of our concept that we cover in the projects that the student turn in, right? I see that they sometimes use srand and they use it correctly. And then all of the things that we've been covering with combinatorics, with, so altogether, you're going to get a little bit more foundation in programming out of a class like this, even though we do emphasize the math. The point is to really look at the math concept and how that's used in programming. And so that way if you need to apply math to solve certain problem, you can translate that into a language that you can write into a program. Okay, and that's my main goal for this class. So at the end, we will get a constructive project in that we will solve a problem, the problem that's asked of us to do, right? And it's a bigger program, of course, but we can take pieces of this class and put it in there, and you would say, okay, this is how I would be able to approach it. And some group or some projects are better than others. And so, but I generally am happy that over the last 4 years that I've taught this class, and I have drastically improved it, of course. Every semester I teach it, I modify something. So, I'm happy to report that it's in general, the projects come out better each time. And that's really nice to see. Okay, in all classes actually. So okay, any question? No question? All right. So okay, so that's it. Make sure that if you're done and if you're happy with your lab, you can upload it, and I can report that this is the only class that I'm actually, this week was, I'm mostly caught up with the grade. I'm guilty in the other classes, even though they're smaller, that I'm not able to do that because it's been pretty busy. But after this week and next week, I think my schedule is going to get a little better. But I will try to make time to share with you some resources that you can use as a student, that will benefit whatever, professionally or things like that. But you should start looking at those. Do not wait until you graduate associates or going into the bachelor. And having that opportunity is good. And also, let me stop this now because just talking.